we are going to try one more example of how to perform a hypothesis test. Let's assume that we have a normal distribution that has a standard deviation of 1. So we do know sigma, it is equal to 1. And we want to verify a claim that the mean is greater than 12. So we want the mean to be greater than 12. That's our alternative hypothesis, which means that the null hypothesis will be that the mean is less than or equal to 12. We definitely need the equal sign in the null hypothesis, and that is because we need to have a distribution to sketch. That distribution will have a mean equal to 12. And we pick a sample of size 36. So when n is equal to 36, remember that the standard error, the standard distribution of the standard deviation of the distribution of the sample mean will be the standard deviation of the population divided by the square root of n. So this is because the variable we are estimating is the population mean. The symbol for the population mean is mu, and that's the one that we use in our hypothesis as the variable of investigation. The distribution will be a normal distribution. It will have a mean equal to the population mean that we have assumed in our null hypothesis, which is 12, and it will have a standard deviation of 1 over the square root of 36. And the square root of 36 is 1/6, so it will have a standard deviation of 1/6. So we will assume that the null hypothesis is true, and we will sketch the distribution assuming that we have a mean of 12 and a standard deviation of 1/6. So 12 and 1/6. 12 and 2/6, which is 12 and 1/3, 12 and 3/6, which is 12.5. And here we will have 11 and 5/6, 11 and 2/3, and 11.5 when we go down by 1/6. The variable on this axis is the variable that we are estimating, which is the mean of a sample of size 36. So the hypothesis test will ask the question, how unlikely is it to get a mean, sample mean of 12.5 or greater? If the distribution of the sample mean follows the null hypothesis with a mean of 12. So we sketch a graph to show how far our x bar is from the normal curve, and our x bar happens to be here. This is the 12.5, which was our x bar, and the probability of having a sample of 36 giving us a mean of 12.5 or greater is the p-value. So the p-value will be equal to the probability of having x bar greater than or equal to 12.5. So the p-value again is the probability that a sample mean will be greater than or equal to 12.5 when the mean equal to 12 for the whole population is assumed to be true. Mathematically, your p-value equals the probability that x bar is greater than or equal to 12.5 in the distribution shown above. So I'm going to use my technology to find the p-value. So for my technology, I used ArtofStat with a mean of 12, a standard deviation of 1/6. Remember, ArtofStat doesn't take expressions, so I had to use as many decimals as I could. And then I asked for the upper tail with a value of x to be 12.5, and I got an answer of 0.13%, or in decimal form, 0.0013. And this tells us that there is 0.13% chance for the sample mean to be greater than or equal to 12.5, which is an unlikely and rare event coming from this distribution. So we can conclude that we have evidence from the sample we collected that the null hypothesis is unlikely to be true. We will reject the null hypothesis, and our conclusion will be that we have evidence to support the alternative hypothesis. That is, we have collected enough evidence with certain confidence to conclude that the mean is greater than 12. So the next question that we want to be answering is, how do we form formally the decision and the conclusion of a hypothesis test? So the systematic way to make the decision of whether to reject or not reject the null hypothesis is to compare the p-value we found with the preset or preconceived alpha. Remember, alpha is the probability of make a type 1 error, and it's called the level of significance. The type 1 error is to reject the null hypothesis when the null hypothesis is actually true, and it may or may not be given to you at the beginning of the problem, but for the purposes of the educational purposes of teaching an introductory statistics class, we will give it to you. So you have two decisions to make. Will you reject the null hypothesis, or will you fail to reject the null hypothesis? And you will do it as follows. If the probability of your sample mean, let's say your sample statistic, is much smaller than alpha, which means the sample coming out of the theoretical population is unlikely to occur, then you will reject the null hypothesis and you will write at the alpha significance level or alpha level of significance, there is sufficient evidence to support that the alternative hypothesis is true. Remember to state alpha and to state the truth statement for the alternative hypothesis in context, based on the problem and the scenario you are addressing. Now, if the probability of the p-value, which is the probability of selecting a random sample from the given population with the particular statistic value or more extreme, is actually greater than alpha, which means you have a probability that is large enough to not be alarming or not give you enough evidence that the theoretical distribution is inaccurate, then you will fail to reject the null hypothesis. You will write that at the alpha level of significance, there is not sufficient evidence to support the alternative hypothesis. Now, two things that you have to remember is that your decision is to reject H sub 0 or to fail to reject the null hypothesis, and your conclusion should only mention whether you can support the alternative or not support the alternative. When you do not reject H sub 0, then that does not mean that we believe that the null hypothesis is true. It simply means that the sample data were not sufficient to provide a support for the alternative hypothesis. So use the following mnemonic device if you want. When the p-val is low, H sub 0 must go. When the p-val is high, H sub 0 must fly. So let's fill in the blanks and see if you can pause the video and fill in the blanks and see if your entries here for when we reject the null hypothesis for when we don't reject the null hypothesis, and how the conclusion should be written will match with what you will see after you restart the video. So if you find a p-value that is smaller than alpha, you have an extreme sample with extreme data. The results of the sample data support the alternative hypothesis. Remember to start your conclusion with at the alpha level of significance. Now, if your p-value is greater than alpha, you will not reject the null hypothesis, and then your conclusion will say that the results from the sample data do not support the alternative hypothesis, and again, don't forget to mention your significance level. Remember that the glossary for this section was exactly what the p-value represents, which is the probability that an event will happen purely by chance, assuming the null hypothesis is true, but also an event as extreme or more extreme than what your sample data indicated. If your p-value is very small, then we have an unusual sample, which means we have evidence that the theoretical distribution is invalid, and we can reject the null hypothesis and support in our conclusion the alternative hypothesis.